Hey Precalc. So today in class we worked some more on simplifying trig identities, and we had a couple of new items for our toolkit. One of the things we learned today in class was that if you find the cosine of negative x, it's equal to the cosine of x. This negative doesn't matter. This is because cosine is an even function. Basically, just a real quick synopsis of what we said in class. If you have like 15 degrees and negative 15 degrees, because cosine is how far we go out, it's the like x coordinate on the unit circle, right? In both situations, we've gone over the same amount, and so that's why these are going to be the same value. We also saw in class today that sine of negative x is equal to negative sine x. So in this case, you're going to pull the negative sign out. And we also saw that tangent of negative x is equal to negative tangent of x. So cosine is what we would call even. Because the negative comes out of sine, it's an odd function, and tangent is also odd. One last thing that we saw in class today, things to remember like cosine squared x. We know it equals cosine squared x plus sine squared x equals 1 from the other day. So from that, we have cosine squared equals 1 minus sine squared. And then just something to be aware of, whenever you have 1 minus sine squared or 1 minus cosine squared, you can factor this as a difference of squares. Because 1 times 1 would give me 1. Sine of x times sine of x would give me sine squared. And then since it's a difference of squares, I need a minus and a plus here so that the middle term cancels out. A minus sine x and a plus sine x would cancel. And so just be aware that sometimes on these problems, you're going to have to use some clever factoring to work your way through them. So this would be an example of some type of factoring. All right, that being said, tomorrow or the next day, we're going to work into proving trig identities. And so what that's going to get basically 2 problems that you're going to need to simplify. Now, for these trig identities, when you prove, I'm going to have you guys always draw a line down from the equal sign to keep the 2 sides separate. This just helps me when I'm grading your work, and it actually helps you probably keep your work separate too, so it's just an organizational tool. Now, if I want to prove that these 2 things are true, what I have to do is use the algebra that we've been learning and simplify them down to the same thing. So it doesn't really matter what side you pick. Sometimes you're going to have to simplify one side and not the other. Sometimes you'll need to simplify both. I'm going to start on the left-hand side and just start trying to simplify. So I know that tangent is sine over cosine. I know that secant is 1 over cosine. And then since I'm multiplying here, I get 2 sine of x over cosine squared. And right now, that's about as simple as I can think to make it. So then once I get this side as simple as I can get it, I'm going to go over to the other side and start simplifying as well. So here I have 2 fractions with different denominators. I'm going to have to get a common denominator. So I need parentheses around these guys. This by 1 minus sine of x on top and on bottom. And over here I'm going to multiply by 1 plus sine of x on top and on bottom. Now when I do that, on top here I get 1 plus sine x minus, and on this side I have 1 minus sine x. And then on the bottom here I have the common denominator 1 minus sine of x times 1 plus sine x. Alright, now I need to distribute this negative. Notice it's important that I have parentheses around here so that I remember to subtract both the 1 and subtract the negative sine x. So I'm going to get 1 plus sine x minus 1 and a negative positive sine x. On the bottom here I can FOIL. I've got a difference of squares, so I know that's going to come out to 1 minus sine of x squared or sine squared x. And then notice here a plus 1 and a minus 1 cancel. I have sine x plus sine x, which is 2 sine x. And from our toolkit, we know that 1 minus sine squared is equal to cosine squared. And so I have the same thing on both sides, I've used trig identities and algebra to show that this side really is equal to this side, even though they don't look like the same thing at all. And then once you get to the same thing on both sides, whatever it is, you're finished. So this would be proof complete. All right, guys, that's it for notes for tonight. I will see you guys in class tomorrow. Thanks.